crushed fingers, hands and arms, eye injuries followed by blindness. The list of possible machinery related injuries is as long as it is horrifying. A good rule to remember is any machine part, function, or process which may cause injury must be safeguarded. There are three basic areas where safeguarding is required. Number one, the point of operation, where work is performed on the material such as cutting, grinding, or boring. Number two, power transmission apparatus, the components of the mechanical system which transmit energy to the part of machine performing the work. These components includes flywheels, pulleys, belts, connecting rods, couplings, cames, chains, cranks, or gears. Number three, other moving parts. It includes all parts of the machine which move while the machine is working. These can include reciprocating, rotating, and transverse moving parts, as well as feed mechanisms and auxiliary parts of the machine. Welcome to HSC tutorial. Today's topic is machine guarding. I'm your host Javed and you are watching Safety First. Let us discuss the training objectives. Number one, accident prevention. Number two, introduce machine guarding and establish its role in today's industry. Number three, introduce basic concepts and techniques of machine safeguarding. Number four, provide machine safeguarding skills for maintenance workers and floor supervisors. What are the program requirements? All employers must install machine safeguards, review job specific hazards, implement corrective actions, conduct hazard assessments, conduct accident investigations, provide training to all required employees, and control workplace hazards by using personal protective equipment as a last resort. If you are new on this channel, kindly subscribe the channel. And if you find the video informative, like, comment, and share. Let us discuss why machine guarding is important. A good program will help to improve quality, improve absenteeism, maintain a healthier workforce, reduce injury and illness rates, acceptance of high turnover jobs, workers feel good about their work, reduce workers' compensation costs, and elevate safety to a higher level of awareness. Dear friends and fellows, let us look how to implement safeguarding program. Implementation of a machine guarding program requires dedication, personal interest, and management commitment. But remember, understanding and support from the workforce is essential. Without their support, the program will fail. Now, let us discuss what is the management role while safeguarding the machines. The management considerations are number one, support the machine guarding effort. Number two, ensure your support is visible. Number three, get involved. Number four, attend the same training as your workers. Number five, insist on periodic follow-up and program review. And number six, implement ways to measure effectiveness. What is the role of supervisory staff? Supervisory staff consideration must be to treat all near misses as an accident, get involved in the guarding of machines, complete the paperwork, work orders, policy changes, etc. to make guarding improvements. Get your workers involved. Never ridicule any injury or near miss. Be professional. You could save a life today. Attend the same training as your workers and follow up on the actions you took. Employees. Let us discuss what is the employee's role to report all accidents and near misses immediately, contribute to make corrective actions, always provide complete and accurate information, report all machine guarding problems or deficiencies, and follow up with any additional information. After discussing the role of management, the role of supervisory staff, the role of the employees, now let us discuss the role of safety department. Safety department should hold regular guarding accident review meetings. They should document the meetings. They have to encourage employee involvement, bring employee guarding complaint, suggestions or concerns to the attention of management, provide feedback without fear of reprisal, analyze statistical data concerning accidents, and make recommendations for corrective action. And lastly, follow up is critical by safety department. Dear friends and fellows, remember any machine part, function, or process which may cause injury must be safeguarded. When the operation of a machine or accidental contact with it can injure the operator or others in the vicinity, the hazards must be either controlled or eliminated. Let us discuss what are the basics of machine guarding. Where mechanical hazards occur, there are three main considerations: the point of operation, power transmission apparatus, and other moving parts. We will discuss these points one by one. The point of operation, where work is performed on the material such as cutting, shaping, boring, or forming of stock. Number two, power transmission apparatus, all components of the mechanical system which transmit energy to the part of machine performing the work, that is power transmission apparatus. Other moving parts, any part of the machine which moves while the machine is working, rotating parts, feed mechanism, reciprocating parts, transverse moving parts, and auxiliary parts of the machine. Let us discuss hazardous mechanical motions and actions. Recognition of these hazards is the first step towards protecting workers from danger they present. While describing hazardous mechanical motions, you have to remember rotating, reciprocating, and transversing. These are the points, and this is the nip point. If finger, hand, or arm, or any other thing will come in between these mechanical moving parts, it will be crushed. It will get injury. What are the hazardous mechanical actions? Actions might be cutting, punching, shearing, or bending. So these are the actions of these motions which we discussed earlier. Rotating motions may include collars, clutches, spindles, vertical shafts, couplings, flywheels, meshing gears, canes, shaft ends, and horizontal shafts. Remember, rotating motions can grip clothing and through skin contact force a limb into a dangerous position. The danger increases when projections such as set screws, bolts, nicks, abrasions, and projecting keys or set screws are exposed on rotating parts. Number two, reciprocating motions. In the diagram, you can easily identify the rotation, the angle, and the way of motion. While describing reciprocating motion, there are two chances, or there are two types of hazards: caught in between or struck by. Number three, transversing motions. It's traveling in running nip points, and you can easily understand in the diagram how it can cause danger for an individual. Have a look on rotating motions. Nip points. These points are indicated by blue arrows. Here are the nip points. It may cause cut of clothing or crushing of fingers or hands. Let us discuss hazardous mechanical actions. First, cutting actions, rotating motions, reciprocating motions, and transversing motions. You have seen in the diagrams three different types of mechanical actions. The danger of cutting actions exists at the point of operation where finger, arm, and bodily injuries can occur, and where flying chips or scrap material can strike the head, particularly in the area of the eyes or face. So these are the dangers. Cutting actions might include bend saws, circular saws, boring machines, drilling machines, turning machines, lathes, and milling machines. Dear friends and fellows, hazardous mechanical actions are still in continuation. You are watching Safety First, and today's topic is machine guarding. Let us discuss punching actions, power presses, and iron workers. The principal hazard occurs at the point of operation where stock is inserted, held, or withdrawn. Shearing, bending actions, mechanical shears, hydraulic shears, and pneumatic shears. The principal hazard occurs at the point of operation where stock is inserted, held, or withdrawn. Have a look on shear terror. Let us discuss what are the requirements for safeguards. Be securely attached. Create no new hazards. Withstand operational conditions. Allow for safe routine maintenance. Allow for safe operator adjustments. Withstand environmental conditions, provide protections from falling objects, prevent contact with hazardous conditions, and create no interference in the conduct of work. These are the requirements of safeguards. These are the requirements of guarding. Now, we will discuss non-mechanical hazards consideration. Power sources are potential source of danger. How will guarding affect equipment operation? Ensure proper grounding of system. Replace frayed, exposed, or old wiring. Consider effects of high pressure systems, extreme temperature conditions, pulsation, vibration, or leaks, noise, or unwanted sounds, cutting fluids and coolants. Dear friends and fellows, let us describe operator training considerations, provide instruction, and our hands-on training. Discuss the purpose of safeguarding, cover associated hazards thoroughly, involve guard designers in the training, describe how to properly use safeguards, describe how safeguards provide protection, describe circumstances for safeguard removal, explain what to do if safeguards are damaged, explain what to do if safeguards are missing. You have to remember defeating, altering, or removing safeguards can cause injury to co-workers and can leave the person performing such actions liable under the OSHA Act of 1970. Dear friends and fellows, let us discuss the control strategy. Number one, engineering controls. Number two, administrative controls. And number three, personal protective equipment. Engineering controls might include workstation design, process modification, tool selection and design, and mechanical assistance. In the hierarchy of controls, this should be the first and number one choice. Administrative controls might include training programs, pacing, job rotation, enlargement, policy, and procedure. And this is second choice. Personal protective equipment may include gloves, shields, non-slip shoes, wraps, eye protection, and aprons. But remember, this will be the last choice. This will be the last resort. While selecting personal protective equipment, you have to remember it must be appropriate for the particular hazard. It must be maintained in a good condition. It must be properly stored when not in use. Keep it clean, fully functional, and sanitary. Do you know the guarding method is dependent on the type of material, the type of operation, method of handling, size or shape of stock, physical layout of the work area, and production requirements or limitations. These points must be considered while selecting the guarding method. Remember, before beginning the process of guard procurement, design, or installation, the equipment manufacturer should be consulted for advice. Generally, power transmission operators is best protected by fixed guards that enclose the danger areas, while the point of operation hazard guarding will vary as per the nature of the equipment. Safeguards are grouped under five classifications: guards, devices, locations and distance, feeding and ejection methods, and lastly, miscellaneous aids. Now, we will discuss in detail about the guards. What is guard? Guards are barriers which prevent access to danger areas. There are four general types. Number one, fixed guards. Number two, interlocked guards. Number three, adjustable guards. And number four, self-adjusting guards. We will discuss these four general types one by one in detail. First of all, we will discuss about fixed guard. Fixed guards are a permanent part of the machine and not dependent upon moving parts to perform its intended function. In the diagram, you can easily understand and identify how a fixed guard can be. Let us discuss what are the advantages of fixed guards. Fixed guards can be constructed to suit many different applications. In-plant construction is often possible, can provide maximum protection, usually requires minimum maintenance, can be suitable to high production operations, and can be suitable to high repetition operations. These are the advantages of fixed guards. Let us look the disadvantages or limitations of fixed guards. It may interfere with visibility. It can be limited to specific operations. Machine adjustments and repair often require guard removal, thereby necessitating other means of protection for maintenance personnel. Number two, interlocked guards. Interlocked guards are designed to automatically shut off or disengage the machine if the guard is opened or removed. Have a look in the photograph. You can easily identify how interlocked guard should be and how it functions. It will give an automatic audible alarm or visual alarm. While the guard is disengaged, it will shut off the machine automatically. Now, we will discuss where interlocked guards might be used: for electrical power, mechanical power, hydraulic power, and pneumatic power, or any other combination of power sources. Interlocks should not prevent inching by remote control if required. Replacing guards should not automatically restart the machine. Let us look. The advantages of interlocked guards: can provide maximum protection, allows access to machine for removing jams without time-consuming removal of fixed guards. The disadvantages or the limitations of interlock guards are: It requires careful adjustment and maintenance. May be easy to disengage gems. Dear friends, colleagues, and fellows, you are watching Safety First, and today's topic is machine guarding. The number three category of guards are adjustable guards, typically adjusted by the operator. Accommodate various sizes of stock, may require additional operator training. And remember, adjustable guards are typically used on band saws, table saws, power presses, routers, and the similar equipment. Let us discuss the advantages of adjustable guards. It can be constructed to suit many specific applications, can be adjusted to admit varying sizes of stock. The disadvantage of adjustable guards are hands may enter danger area. Protection may not be complete at all times, may require frequent maintenance and or adjustment. The guards can be defeated by the operator and it may interfere with the visibility. These are the limitations or disadvantages of adjustable guards. Now, the number four category of guards is self-adjusting guards. It adjusts automatically to the work. It accommodates various sizes of stock. It may require additional operator training. Remember, self-adjusting guards are typically used on radial arm saws, table saws, circular saws, routers, jointers, and the similar equipment. The advantages of self-adjusting guards are off-the-shelf guards are often commercially available, but the limitations are its protection may not be complete at all times, may require frequent maintenance and or adjustment. It may interfere with the visibility of the operator. After discussing four types of guards, now we are going to discuss about the devices. Devices fall into four general types. Number one, presence sensing devices. Number two, pullback devices. Number three, restraint devices. And number four, safety trip controls. Devices may perform one of several functions. Stop a machine if a body part is in danger. Restrain or withdraw a hand if it is in danger. Require activation by the use of both hands and provide a barrier synchronized to the operation. Let us discuss the usage of presence sensing for photoelectric, for radio frequency, and for electromechanical devices. Presence sensing devices might be used. Remember, before beginning the process of procurement, design, or installation, the equipment manufacturer should be consulted for advice. Number two, pullback devices. The usage of pullback devices are attached to race, positioning critical, adjustment critical, maintenance critical, training critical, must stop machine immediately. Have a look in the diagram. Nylon pullback straps attached to the wristband of the operator. Number three, restraint devices. Restraint devices use cables or straps affixes to hands, may need feeding tools, adjustment critical, positioning critical, maintenance critical, training critical, must restrain body part from hazard. You can easily identify the restraint device in the attached photograph. Number four, safety trip controls, body trip bars, hand and arm trips bars, trip wire cables, positioning critical, adjustment critical, maintenance critical, training critical, manual reset needed, and must stop machine immediately. This is the use of safety trip controls. Now, let us discuss two-hand control device. It needs constant pressure, needs concurrent pressure, positioning critical, adjustment and maintenance critical, training important, and it has the capacity to stop the machine immediately. Number four, location distance safeguarding. Position dangerous areas of machines so that they are not accessible during normal operation. Examples include position hazard areas against a wall, locate hazards out of reach of operators, add enclosures or fences to restrict access, design stock feeding openings away from hazards, position of operators control station away from hazards. Let us discuss the feeding and ejection methods. Automatic feeds fed from rolls indexed by machine. Semi-automatic feeds fed by chutes, movable dies, dial feed, plungers, or sliding balusters. Automatic ejection might include air or mechanical ejection. Semi-automatic ejection might include air or mechanical ejection initiated by the operator. Robotics perform work usually performed by the operator. Dear friends and fellows, manufacturers should be consulted to determine feeding and ejection add-on options, latest technology available, best available technology, operator training requirements, maintenance staff training requirements, cost estimates for upgrades, and feasibility assessment information. The last one is miscellaneous aids. Example of possible applications: awareness barriers, not adequate for continuous hazards, color coding of hazard areas, signage, shields, for example, splash, eye protective, or thermal, etc. And lastly, holding and positioning the tools. These are the examples of miscellaneous aids. Now, we will discuss the guard construction. Many machines come with safeguards. Many older machines now have safeguards available. Manufacturers are increasingly more concerned with liability, and companies not specialized in guarding issues. User designed and installed guards often the only practical solution for older equipment. It can be designed and built to fit unique and changing situations. It can be installed on individual dies and feeding mechanisms. It can help to promote safety consciousness in the workplace. Sometimes don't conform as well as builders design. It depending on talent and resources may be poorly designed. Point of operation guards may be complicated by the number and complexity of machines if used. Must fully safeguard the employee, must allow production to continue. Hazard analysis is usually required. If poorly designed, built, or installed, guards may create a hazard rather than eliminating the hazard. While discussing mechanical power transmission operators guards, the only opening usually needed are for lubrication, adjustment, repair, or inspection. Dear friends and fellows, let us discuss the guarding material. Under many circumstances, metal is the best material for guards. Guard framework is usually made from structural shapes, pipe, bar, or rod stock. Fill material generally is expanded and perforated or solid sheet metal or wire mesh. It may be feasible to use plastic or safety glass where visibility is required. Guards made of wood generally are not recommended because of their flammability and lack of durability and strength. However, in areas where corrosive material are present, wooden guards may be the better choice and better option for machine guarding, for maintenance, or inspection. One another aspect that is lockout tagout. Let us discuss in the lockout tagout procedure who is the authorized employee. The person who locks or tags out machines to perform servicing or maintenance is known as authorized person or authorized employee. Who is the affected employee? An employee whose job requires him or her to operate or use a machine or a piece of equipment on which servicing or maintenance is being performed. That is called affected employee. If you are interested to know in depth about lockout tagout procedure, kindly click on the link that is appearing on your screen. Dear friends and fellows, you are watching Safety First, and today's HSC tutorial topic is machine guarding. Now we are discussing lockout tagout. Normal operations. Number one, covered an employee must remove or bypass guards or devices. Number two, covered where employees are required to put a body part in a machine process area. Number three, covered where employees are required to put a body part in a machine having a danger zone. Wherever there are these conditions, lockout tagout procedure is mandatory. It must be applied, it must be complied and 100% followed. Dear friends and fellows, let us discuss the tips that you might use for your contractors or subcontractors. Remember, you control your facility or area. Review their procedures with them before starting the job. Determine their safety performance record. Determine who is in charge of their people. And lastly, how they will or their activities will affect your employees or your workplace. And that's it. Training session is over now. If you have any question, please ask in the comment section down below. Thanks for watching. If you find the video informative, please like, comment, and share. Hope to see you soon with a new HSC tutorial. Till then, take care, good luck, and Allah Hafiz.